My name is David Robotham.
My name is Ryan Kirby.
And I'm Brian Israelson, and we're all students here at Utah State University, currently in the ECE 3710 course. It is microcontrollers, and for our microcontroller project, we created an automatic dust collecting system. As far as our qualifications go, though, we have had extensive experience programming C and C++, and also experience outside working at Hill Air Force Base and doing extensive research in different fields, including chemical reaction networks and other modeling language endeavors.
What our project will do is in a workshop, when you turn on a table saw or a bandsaw or any other power equipment like that, the dust collection system will automatically turn on to start collecting the dust that's created from those cuts. We've also set it up so that if you need to just use the dust collection system to vacuum up leftover sawdust, we have implemented a keypad to enter in a timer so that you can set it for anywhere from 1 all the way up to 99 minutes, as much as you need.
Okay, so for our automatic dust collecting system, we are making a system that automatically turns on a dust collector when a saw is turned on. It also has an input from a keypad that will turn on the dust collector for a specified amount of time. We implemented and tested our design on a outlet right here, which is connected to a solid state relay, as well as a fan, which is seen down below here, which is connected right up to this power strip and has this current sensing relay connected to it. As far as the requirements of this design, the fan turns on, which simulates the saw itself. Then this solid state relay will let current flow through and charge the cellular device. As far as the dependencies, the current running through here is adjusted so that when the fan is turned on full blast, it will trigger, and when it is on its lowest setting, it will not trigger. The Bluetooth modules are hooked up to 3.3 volts. The Bluetooth modules can be seen here and right there on both boards. And the solid state transform is also hooked up to 3.3 volts right here and the ground pin right there. So when there's a difference of 3.3 volts between the output and the ground, then it will trigger the current.
The hardware we chose was 2 Bluetooth transceivers to communicate between the two boards using UART. Those 2 transceivers can be seen here and here. The idea behind our design is we want to hook this up to in a wood shop, something to like a table saw or a bandsaw. And right now we have the fan that you can see on the floor here representing the table saw. What happens is once the fan is turned on, or in this representing the table saw being turned, well, it will close these 2 contacts and it will tell the microcontroller this saw is on. What the microcontroller then does is it sends a command to the Bluetooth module, which will send it over to the master device over here, which receives that command, and it says this saw has been turned on. We're going to turn on the dust collector now. The dust collector is represented by this solid state relay here, and we're using a phone to demonstrate that it is indeed turning on in this demonstration. The other design specification that we had is we added a keypad so that you can type in a number of minutes that you want the dust collector turned on independently of a saw, and that can be anywhere from 1 minute all the way up to 99 minutes. For our code, what we did is we decided to use the HSI clock. That would make the math for our timer easier in later steps. So for the first thing, we enable our GPIO pins, which can be seen in this function. We enable C and we enable B. B handles the handler and C handles our keypad functions. Next thing that happens is we enable our UART so that we can read and write between the 2 Bluetooth modules, and we then enable our interrupt to operate on the to operate to activate the keypad. And finally, we call USArt read. What this function does is it sits and it waits for a command to come in from the slave device telling the dust collector to either be turned on or to be turned off. We also implemented a keypad function. The keypad function is activated through the interrupt. Once the keypad function is called, it will pull and figure out how long to run the dust collector for, independent of having a saw on. The way that this is done is the timer takes in the variables and allows the user to enter anywhere from 1 minute to 99 minutes. And then from there, it jumps up into the countdown function where it will count down until that timer has expired, and then it will jump back in waiting for another on or off command from the slave device.
Okay, so for our slave microcontroller, we have this main function as you can see here. First thing we do is enable the pins. We enable them for the UART, which is found on PC 1011 for the Bluetooth module. And then we enable PC3 as an interrupt hooked up to the current sensing relay. The current sensing relay will trigger the interrupt handler found up here, starting on line 46. And when it is activated, it will give a stop right command, which just sends stop over the Bluetooth module. It waits for the current sensing relay to stop its signal and then gives a go right command, which starts or gives a go command through the Bluetooth module. This is opposite of what you would expect because the current sensing relay we got is the NC50 instead of the N50, and because of that, its logic is backwards from what we anticipated originally.
Okay, so here we're going to demonstrate it. Right now the fan is in the off state, and so as Brian will turn it on, you can see the current sensing relay turns on and the phone is now charging. And the phone will keep charging as long as the fan is on. But when it's turned off, the phone is now not charging. So that was the one way, and then we also have, through the keypad, we can get the phone charging. So if we hit here, and then we do, say, 10 seconds, then, see, it starts charging, and then, after 10 seconds, it just stopped charging. And so you can see that the whole thing was able to work. We only ran into a few problems. One of them was in our program when we were trying to program the current sensing relay, that there was a random 2 in it, and it took us a few hours to find the random 2. And another problem we ran into was that we accidentally had the slave and the masters backwards, and so once we switched that, it worked a lot better. And the final problem that we ran into was that we had a power outlet that was not working correctly. But in conclusion, it all worked as planned. So when we hooked this up to the table saw and the dust collector, it will be able to work exactly the same. The Bluetooth will be able to interface with each other, and it will all work.